In this video lesson, we will learn how to solve exponential equations using logarithms. We learned how to solve regular exponential equations in a different video lesson, but that method used earlier does not always work. So first I'll show an example where the sort of easy method does work. 3 to the x equals 9. The way this is solved in my different video is by rewriting 9 as 3 to the second. And since we have 3 to the x and 3 to the second, then x must equal to 2. However, it's not always possible to rewrite your equation so that both sides have the same base. So I'll show you a second method of doing this same problem, which will give you the same answer, but this method will always work, even if the bases are different. This is how the method works. We start with 3 to the x equals 9, our original exponential equation, and then we take the log of both sides, the base 10 logarithm. Now we have 3 to the x, so by the properties of logs, we get x times log of 3 equals log of 9. But now all we need to do is divide by log 3 on both sides, and we get x equals log 9 over log 3. You can calculate this exactly on the calculator, and it will tell you that this is actually the same as 2. The answer that we got before. So this is the second method of solving exponential equations. Now let's do an example where the easier method, method 1, does not work, but the second method does. The example will be 4 to the x equals 19 equals 19. So first of all, 19 doesn't factorize, and you can't write it as 4 to some easy power. For example, earlier we had 9. 9 is 3 squared, and that's easy to see. But 19 can't really be rewritten like this. So there's not an easy answer for this. There's no simple x. So we're forced to do method 2. We take the log of both sides, and since we have 4 to the x inside of the logarithm, since x is the exponent, we can pull it outside of the logarithm by the properties of logs. So we get x times log 4 equals log 19. When we divide by log 4 on both sides, we simplify the expression to get x equals to log 19 over log 4. This is our final answer. If you want a more definite answer, like a number, then you can plug this into your calculator very easily, and you'll get a crazy decimal. Let's do some more examples. For example, 2 to the x minus 1 equals 12. So first, we're just going to take the log again. And also we can use any logarithm. So we can use, so far we've been using the base 10 logarithm, but we could use the natural logarithm, ln. So in this case, just to try out something new, we will use the natural logarithm. The answer will work the same way, and you'll solve the exact same way, but it doesn't matter which logarithm you use. In any case, x minus 1 is the power, so we can pull it in front. So I get x minus 1 times the natural log of 2 equals the natural log of 12. Again, we divide by ln 2 on both sides. We get x minus 1 equals ln 12 over ln 2. To find x, all you have to do is add 1 to both sides. And we get natural log of 12 over natural log of 2, all plus 1. And that is the final answer. Now we will do one final example. Three to the 3x minus 1 equals 17. So first we take the log on both sides. Let's do the natural logarithm again. And then, since 3x minus 1 is the entire power of 3, we can pull it in front of the log to get 3x minus 1 times natural log of 3. And this equals to the natural log of 17. Again, we divide by natural log of 3. Then we get 3x minus 1 equals ln 17 over ln 3. Let me correct that there, it's ln 3. Alright, now all I have to do is, first, we add 1 to both sides. Now we have 3x, so we want to divide by 3 on both sides. And as our final answer, we get x equals ln 17 over 3 ln 3 plus 1/3. And that is the solution. Thank you for watching this video lesson. I hope it helped.